All right, hello and welcome to our video on polynomial synthetic division. So you can start by pausing the video and trying the warm-up on your own. All right, let's see how you did. You had to you had to convert this quadratic into vertex form and graph it. So here is the answer key. All right, so what this video is on, once again, is on synthetic division. So usually I teach long division before synthetic division, but the way that this chapter is broken up, you're going to learn synthetic division first, which is not that big of a deal because it's easier. But we must understand what it is, why we would want to use it, so on and so forth. So there's two methods to divide polynomials. One of them is long division, which is the example on the left, which we're not learning today. We will learn. However, if you're dividing by a linear binomial, so if the divisor is linear, it's not the best method to use. So long division is not the easiest method if you're dividing by a linear binomial. If you are, then we want to use what's called synthetic division, and that's what we're learning today. Okay, so this is what long division looks like. So here's the original problem. Divide this polynomial by, and if you look right here, this is a linear binomial. If the lead coefficient is 1, even better, right? But if it's not, you can still do it. I don't love to do it, but preferably a linear binomial with a lead coefficient of 1. We can do it if it's not 1. It's not a big deal. Okay, so here's what long division looks like. So this divided by x minus 3, I'm not going to go through the process of. This is what you get as an answer, okay? So what we're going to do is I'm going to teach you how to do this using synthetic division, because if you look at long division, it is what it says. It's long, right? So I'm going to teach you how to do synthetic division instead, and then we're going to see what the commonalities and how to get the answer. And you're also going to see that it's a lot shorter of a method. Okay, so what you're going to do is you're going to look at what you're dividing, okay, and you're going to make sure that there's no term missing. So it has to go, this is to the 4th power, then I needed the 3rd power, 2nd power, 1st power, and my constant. Let's say that this wasn't here, then I would put plus 0x cubed in its place because I would need a placeholder for it. But that is there. Okay, so what you're going to do is you're going to write down the coefficients on each of your terms. So the coefficient on my x to the 4th is a 1. Then I have a -6 on my x cubed, a 4 on my x squared, an 11 on my x, and a 2 is my constant. And then what I'm going to do is I'm going to put these in an L shape, okay? All right, so now what I'm going to do is I'm going to look what I'm dividing by. I'm dividing by x minus 3. So what you're going to end up dividing by is what's called the root or the solution or the 0. So basically you set it equal to 0 and solve. If I do that, I get 3, so I'm going to synthetically divide by a 3. I tend to write the 3 first, then the L, and then the numbers inside, but it doesn't hurt to do what I just did. Okay, so here's how synthetic division works. The first thing you're going to do is you're going to drop this number, and that's a 1. And it can be any number, just the lead coefficient, right? And now what synthetic division involves is multiplying and adding. That's it. So what you're going to do is you're going to multiply these two numbers. So 3 times 1 is 3. You're going to write that right here. And then you're going to add these two numbers. -6 and 3 is -3. And then you're just going to repeat the process until you're done, okay? So multiply these two numbers. 3 and -3 is -9. Write that here. Add, which is -5. Multiply 3 times -5, -15. Add, that's -4. 3 times -4 is -12. Add is -10. Okay, so now what I want you to do is I want us to compare these numbers to this. What does the final result of the -10 represent? So what does that -10 represent in our answer? So if we look here, what is this -10? If you look, it's the remainder, right? So the -10 is the remainder. And what do the 1, -3, -5, and -4 represent? 1, -3, -5, -4. Those are the coefficients on our terms. So what we're going to do now is we're going to write our answer because we have no answer written, okay? So x, or this, divided by x minus 3 is, and now I have to write this as my answer. So I have to make sure I can go from this to this, okay? So what you're going to do is you're going to look at what you started with. We started with an x to the 4th power up here. Okay, x to the 4th power. We are dividing by a linear binomial. It'll always be a linear binomial, so it's going to go down 1 degree. So if I started with the 4th power, that means that this is going to be an x cubed. This is my x squared. This is my x. This is my linear term, and the -10 is my remainder. So sometimes you'll see teachers put a box right here to remind you that it's the remainder. Okay, so now we can write our final answer. Instead of writing 1x cubed, I'm just going to write x cubed minus 3x squared minus 5x minus 4, and then you do plus, your remainder goes in the numerator, which is -10, over what you were dividing by, x minus 3. So it's -10 x minus thirds, right? And there's your answer. People will always ask me if they can just put a minus here and get rid of the negative in the numerator. And for this particular problem, yes. But it gets dangerous when we're not using synthetic division and you're doing long division, and your remainder is more than just a constant, and it's like, let's say, a linear binomial. And if you take that negative and just throw it in front, it's not right. So I just say, just do it this way, okay? All right, so let's go ahead and try. I think we have 3 problems to try together, and then the rest are all on your own. So on this little blurb right here, it just says that it's important to notice that the coefficients for every power of x less than or equal to the degree of the polynomial must be written, or the numbers will be misleading. So in order to use synthetic division, we have to have a coefficient for every term. If you skip over one, then if you're writing down, let's say, to a 4th power and it's skipped over a term, synthetic division is going to think it's a 3rd power because that's how many terms you would do for a 3rd power. So you have to put a 0 as a placeholder, long story short, okay? So if the term is missing, the coefficient is 0. Observe. All right, so let's go ahead and do this problem right here. So if you check before, you shouldn't mess it up. So I have x to the 4th. There is no x cubed, so that's plus a 0x cubed. Then I have 1x squared. I have no x's, so that's plus 0x, and then my constant is a -5. So if you do that first, you hopefully won't forget the zeros. All right, I'm synthetically dividing by 1, because if I set x minus 1 equal to 0, I get 1. And then my coefficients are 2, 0, 1, 0, -5. And if it's a 4th power, you should have 5 numbers written in there. That's another way to check to make sure you didn't make a mistake. Also, like, double check your signs. The negative is on a 5, but nothing else, so I'm good. All right, so once again, the process: drop the 2, multiply 1 times 2 is 2, add 2 and 0 is 2, multiply 1 times 2 is 2, add 1 plus 2 is 3, multiply 1 times 3 is 3, add 0 and 3 is 3, multiply 3 times 1 is 3, add -5 and 3 is -2. And once again, this is our remainder. Okay, so now we can write our solution. This was an x to the 4th, so if I divide an x to the 4th by a linear binomial, it's going to go down to a cube. Quadratic, linear, constant, my remainder. All right, so my final answer is 2x cubed plus 2x squared plus 3x plus 3 plus -2 over, and we were dividing by x minus 1. Voila. Easy peasy, right? Okay, 2 more, right? And then I don't feel like I need to do 2 more linear binomials with a lead coefficient of 1 because I think you got it, right? So what I have here is this is dividing by a quadratic, and the other one has a linear binomial with a lead coefficient of 2. So they're like, what do I do with that? So personally, if I saw this, I would say I cannot use synthetic division and I would use long division, okay? But we haven't learned it yet. So what do I want you to do, okay? If you look at the denominator, okay, if you look at the denominator, It is factorable, and it could factor into two linear binomials. So what we're going to do is we're going to factor it. That way we can see two linear binomials, okay? So this is equivalent to 2x to the fourth. If there's any terms missing, I'm going to put 0 placeholder, but I don't know if there is. Let's see. Minus x cubed minus 11x squared plus 14x minus 8. No, there's no missing term. Divided by, and then I'm going to factor the denominator to x plus 5 times x minus 2. So I have two linear binomials. Okay, before we do this problem, okay, I want to bring us back to like basic math. If I asked you right now, what is 864 divided by 12? Don't use a calculator. Like, could you do it? Yes. Could you do it, you know, the long division way of 864 divided by 12? How many times is 12 going to 86? Yes, you could do it that way, okay? But you could also say that 864 divided by 12 is the same thing as 864 divided by, and then 12 is 2 times 2 times 3, right? 12 is 2 times 2 times 3. And the reason I can break it into these factors is because I can divide by 2 very easily. So what I'm going to do is I'm going to divide this by 2. 864 divided by 2 is 432. Now I'm going to divide by 2 again. 432 divided by 2, that's 216. And then I can divide by 3. 216 divided by 3, 21 divided by 3 is 7. 6 divided by 3 is 2 is 72. So the answer is 72, right? Like, I know it took 3 steps, but like, I personally think that's easier, right? So think about it this way. If you're dividing by something and it's factorable, you can break it into its factors and divide by each of those factors. But notice I divided the first thing by 2, and I got this, and then I divided that by 2, and then I got this, and then I divided that by 3. So consecutive, keep going. I didn't divide 864 by 2, divide 864 by 2, and divide 864 by 3. I kept going. So just keep that in mind. Okay, now back to this problem from that sidebar. Let's go ahead and synthetically divide this. I'm going to write down my coefficients. There was no skipping. So 2, -1, -11, 14, and -8. So I'm going to synthetically divide. I have to divide by -5 and by 2. So now I have to pick which one I'm going to start with, okay? So I personally would pick the 2 because that's going to make, that's a smaller number, and multiplying by 2 is easier. And then I can then do the -5, and I'll have to do it with less amount of numbers, okay? But also, if I do it with the 2 and I don't get 0 as a remainder, then I have to switch to the the -5. And if I don't get a -5, I don't get a 0 as a remainder, then I can't synthetically divide by these two linear factors. So long story short, in case you're like, what? One of them has to be a 0. One of them has to give me a remainder of 0 in order for this to even be possible. I'm hoping it's the 2, because if it's not, then I have to switch to -5. And if the -5 doesn't work, then I can't divide this using synthetic division. We'll find out pretty quickly here. All right, bring down your 2, multiply it's 4, add that's 3, multiply that's 6, add that's -5, multiply that's -10, add that's 4, multiply that's 8, add that's 0. Yahoo, there's my remainder. Okay, so remember, I'm now going to continue to divide. So now I'm going to divide this, which is 2x cubed plus 3x squared minus 5x plus 4. I'm going to divide that by -5. I'm glad I started with the 2 right now. Okay, so I'm going to keep going. Drop the 2. Multiply, that's -10. Add, that's -7. Multiply, that's 35. Add, that's 30. Multiply, that's -150. Add, that's -146. And that's not a 0, so I'm so happy I didn't start with it because I would have had to switch to the 2. All right, remember this is my remainder right here, okay? Now as a reminder, I already said it, but we divided a fourth power by a second power, so our answer should be our x squared. But another way of looking at it is we divide by a linear binomial here. This was our x cubed, x squared, so on and so forth. And then we divided by a linear binomial again, so this is our x squared, x constant remainder. So our final answer is 2x squared minus 7x plus 30 plus negative 146 over, and we were dividing by x squared, oopsies, x squared minus, or plus 3x plus minus 10. Okay. All right, last but certainly not least, we have, oh no, is that over x? Yes, okay. Last but certainly not least, we have, oh, that was when I was dividing by x minus 5 though, so I gotta change that to x minus 5. X minus 5, or sorry, plus 5. Because that was when I was dividing by x plus 5 and the negative 5, 0, right? Because I had already broken it down to this. My bad, I almost put down the original. Okay. All right, last but certainly not least, not much more difficult, right? Go ahead and write down your coefficients. I have cube square linear constant, so no terms are missing. 6x, nope, 6. I almost did long division. A negative 15, negative 87. I don't like that those numbers are big, but it's okay. And a negative 30. All right, so to get what you're dividing by, you remember you find your root 0 solution, whatever you want to call it, by setting 2x plus 5 equal to 0 in solving, and you get negative 5 over 2. And remember, this is your remainder. Okay? All right, let's go ahead and do this. Drop your 6. All right, multiply. Remember, multiplying by negative 5 halves is just multiplying by negative 5 dividing by 2, or dividing by 2 and multiplying by negative 5. So negative 30 divided by 2 is negative 15. I get negative 30. So I get 150 divided by 2, which is 75. That's negative 12. That is positive 60 divided by 2, which is 30, and 0. Okay. All right, so that was an x cubed, so this is an x squared. An x, constant remainder. So my final answer is 6x squared minus 30x minus 12. All right, so that also means that 2x plus 5 is a factor, okay? If you get a remainder of 0. All right, so you can go ahead and pause the video and try the rest of them on your own. And let's see how you did. So there's your answers. You can pause the video again to check them and see if you made a mistake. Usually it's obviously something very little, but that's it.